Hi everyone and welcome to this morning's session. My name's JP and I will be your moderator. And I'd love to introduce Anais to you, who's going to be talking to you about container security today. She's going to be talking about how containers and orchestration are implemented and some awesome security edge cases. So the format of the session is roughly 50 minutes of talk and 10 minutes of Q&A. If you would like to submit your questions in the Q&A in Hoover, that would be awesome. And feel free to utilize the chat to interact with the community. So take it away, Anais. We're looking forward to this.
Awesome. Thank you so much. So yeah, I'm going to give this presentation a wander through the world of container security. Now I have to mention that I jumped in for my colleague, Rory McCune, who could sadly not give the presentation himself. So the entire content is by him. I'm just the one who's presenting it. I also have his demo recordings. So I'm going to show in between his demo. So it's a joint co-speaking presentation in a way, but he's just not going to be here live. Amazing. So let's get started. Well, something a bit about Rory, who created this content. He's an ex-pen tester and IT security person. He worked in the security space for a very long time. He's very experienced in that field, different areas. Now he's a cloud native security advocate for Aquam, and he's also one of the authors for the CIS benchmarks for Docker and Kubernetes, and a member of SIG Security in SIG Hong. So he's very active in the cloud native security space. And this is kind of his mascot, his logo over there, which I think is really cute. So we kept it there. Now, a bit more about myself. Who am I? Why am I giving this presentation? So my journey is not as detailed in the security space, let's say, which can have benefits. So I was working in the blockchain and the open source blockchain space for some time, ended up there in developer advocacy. And then at the end of 2020, I decided that I actually want to change industries. I want to explore something new, something more infrastructure focused as well. So I got started in the cloud native space as developer advocate. And around the same time, I started my YouTube channel where I basically share tutorials on using Kubernetes, on using containers and different tools across the cloud native ecosystem. Last year, I tried myself as site reliability engineer. That didn't last too long because I got pulled back into the open source, full-time open source world. And now I'm an open source developer advocate at Aqua Security. I also just want to share that I reached 10,000 subscribers on YouTube, which I'm very excited about. So if you're one of them, big shout out to you. Yeah, just one of those achievements that I'm really happy about. Now, before we get started with the content itself on like container security, what is container security, I just want to kind of share with you why we're talking about it in the first place. So Rory included this pretty picture in the original presentation. I was like, oh, it's a nice picture. I don't want to delete it. The way to think about container security in the cloud native landscape is really just like an ever-changing landscape. So since I got started in the cloud native space, I've learned so many new technologies. Well, when I got started in my first role at the end of 2020, it was actually the first time that I Googled what is a container. And since then, I've went over using containers, deploying containers, using Kubernetes clusters, using different cloud native applications to manage my workloads on those clusters, and so on. And there was always something new popping up. And also, just over time, there's so much new that you just come across if you're in this environment. And some things will stay the same over longer times, other things are just consistently changing. And I think this is a really nice metaphor just to highlight that. No, more specific to container security, why are we talking about this in the first place? A lot of people, when I talk to them, they might not be using Docker or Kubernetes or containerization yet. And that's cool. But why do we want to start talking about it? Why do I like talking about it? Well, first of all, I really got into this space only knowing containerization and Kubernetes. So this is what I know. This is my perspective. I don't have experience of infrastructure management before that. But here's the Stack Overflow 2021 survey. And Kubernetes and Docker are in the top 5 technologies that developers are adopting. It's really something that more and more people get involved with. We could also just see it at the recent KubeCon in Valencia. There were 7,000 people who attended in person, and I think over 11,000 people attended virtually. online. So there are lots and lots of people entering the space with different perspectives, with different experiences. People like me who are completely like who don't have existing experience until they get started in this space. So we have to keep all those different user groups in mind. Now, also here at this point, I want to mention when I talk about Docker, I'm most of the time talking about Docker containers. Now, if you're already experiencing containerization, you might know that there are different ways to create containers, not just Docker, but in this case, when I'm talking about Docker, I'm mainly talking about containers or the company. I don't want to disregard any of the other containerization technologies out there, however, so that's just why I'm mentioning. Now, another thing that we need to highlight, that we need to focus on, is that across the cloud ecosystem, across the cloud space related to Kubernetes, there are lots and lots of different vendors, lots of different distributions. And all of those different distributions, they do some things kind of differently. So when we're talking, for example, about container security, we have to keep in mind that it will vary slightly between different installations, different distributions, such as Kubernetes has different distributions across different cloud vendors, and they will all be slightly different in how they, especially like at the lower levels, on how they handle things. But this image is just, again, to illustrate, like, this is a really complex ecosystem with lots of different moving parts, and we just have to keep that in mind, that it's very complex. So when we talk about one thing, it always will depend on how it applies to something else. Now, something else we want to highlight is that there are actually around like 1.2 million public hosts that use Kubernetes under the hood that you can find on the internet. Now, these include all kinds of clusters, also clusters that somebody might have spun up by themselves to play around with and then expose it to the outside world, which is not something you should be doing. And it's definitely something that I did the first time I was using my own Kubernetes clusters and playing around with it. And it's something that you want to avoid. So out of those hosts, all of those hosts that we can find that using Kubernetes under the hood, those really like encompass everybody, like all kinds of users. And obviously, given that there's so many, there's a lot of attack surface and different vulnerabilities that are found in each of those different environments. We have a research group at AppSecEU, which is there basically to put out honeypots and just see how attackers are exploiting them, how attackers are, like, what kind of strategies are they using, right? And well, a lot of these clusters, or like some of these clusters, I don't know actually a percentage, but some of these clusters are really just users who want to get started, right? Who don't want to be in a situation where they expose themselves to unnecessary security risks. So whether you're just getting started or your experience with Kubernetes, container security and Kubernetes security is something you should think about from the start. Now, I see that there are 2 messages in the chat, but I only have 1 screen. So please, if there's something I should pay attention to, moderator, just jump in. That would be highly appreciated. Otherwise, I'm going to continue the presentation. So let's talk more about container security and then how it relates to cloud native security in Kubernetes. When we're thinking about containerized processes, so our container, it's ultimately just a Linux process that's isolated through different layers from the underlying host. It's not a virtual machine in that way. It operates differently to a virtual machine. And I could go into more detail and I could show you like those standard diagrams where you basically see a virtual machine and the different layers of a virtual machine, and then you see in comparison a container and how the container kind of the stack that it utilizes. But ultimately think about a container not as something like how should I compare this? I wouldn't say like infrastructure. So when I think of infrastructure, it's like something usually something I don't know, more tangible, I would say, versus a container more like a process, like an evolving process that changes its state. And then you have different layers, like the further down you go into the stack, that help you to isolate it from the underlying host. Now, when I got started with containerization, and you might be somebody who's getting started with containerization, you might not think about all those different layers. And to be honest, the further down the stack I go, the more I lack in knowledge on actually how to make the best out of those different components, of different layers. Now, here's the first demo. Let me just show it to you. I hope you can hear it.
So what we're going to do here is we're going to demonstrate how containers are actually Linux processes. First off, what we'll do is we'll do a PSEF and we're going to grep for Nginx. Just to say at the moment, sure, we don't have any Nginx processes currently running. So when we run that command, what we get back is just our grep command. So there's nothing currently running in the way of Nginx. What we're going to do now is we're then going to run a new Docker container using the Nginx image. So we'll do docker run, name, web server, we'll call it web server, run it in the background, and we're going to use the Nginx image. So that's going to go away and find and pull that down onto our local Docker install. And as you can see, that's done that now. And if we do docker ps, we can see that Docker has this new web server container running. But from a host perspective, what does that actually think? Because like the Linux host doesn't actually know anything about containers, it just knows about processes. So if I run our ps command from before, what we can see is actually, as far as the host is concerned, this is literally just Nginx running on the machine. And that's essentially how a Linux host sees Docker containers. And we can actually kind of demonstrate that as well through another kind of mechanism. If I do docker exec, just executes a command inside of a Docker container, and we're going to execute something inside the web server container, and we're going to create a new file. So that's created a file inside the container. I can actually get to that file without actually using Docker at all, just by using Linux commands, because this is literally just a Linux process. We can get essentially this here, which is the process ID, and what we can do is we can say it'll be sudo ls/proc. So proc is a special Linux file system that holds all the information about running processes, and we're going to find information about that process ID, and we're going to say show me the root file system of that process. And usually when you're doing it with ordinary processes, you'll see the ordinary root file system. But because we're using namespaces, which is how Docker isolates resources, we should see something different. And what you'll see is this is the root of the Nginx image, apart from this here, which is the minute file that we just created. So as you can see, from a host's perspective, Docker containers are literally just processes.
Amazing. So this is the first demo. We have multiple demos throughout the presentation. I'm sure I can share everything afterwards as well, so you can revisit that, maybe play around with the different demos yourself. So ultimately, to summarize, Docker is really command execution as a service. Now, something to know about Docker, if there's something you're taking away from this presentation, it has a very flexible security model. And flexibility is great if you know what you're doing. No, but it adds, obviously, flexibility also adds more complexity to the mix, meaning there are more options for us to make errors, right? The more options we have, the more wrongly configured installations we can have. And ultimately, every user who has access to Docker on the host should be considered a root on that host. That's really important. And we will demonstrate it in the next demo, because this is ultimately the most pointless Docker command ever that you see here. And we will show that now in the next demo of why it's the most useless Docker command ever.
So, as we said, one of the main things about Docker security is that any user with rights to run Docker containers can easily become root on the host. And we can see that as demonstrated here. At the moment, we have a user who's an ordinary user of the system who has rights to run Docker commands. And what we can do is we can pick up the Docker command from the previous slide, and we can actually run that on this machine. So what we'll do here is let's walk through it before we hit enter. We're going to do docker run, and we're going to get a shell inside the container that we're going to run. We're going to add the -- privilege flag, which says basically make this privilege, turn off all the security. And then we're going to add these three flags here, which basically say, give us access to the host's resources, the host's PID, host net, and host IPC. We're then going to mount a volume from the root of the underlying host into /host inside the container, run the busybox image, and then use the command chroot/host. And you can see before we run this command, we are the RORIM user on this machine. And then when we hit enter, it'll say, I can't find this image. It'll go and get it. Once it's downloaded it, we can then see we've changed user, and we are now the root user. So it's just showing that any user with Docker run access can get to be root on a machine very easily. And this is essentially by design.
Awesome. Well, not awesome, but I hope that kind of illustrates it. Now, so how does it relate to Kubernetes? How do containers relate to Kubernetes? What actually is Kubernetes? Lots of people who are using containers, who are using maybe Docker, might not be using Kubernetes. And Kubernetes might also not the best option for you if you're using containers to manage and run those containers. But here's basically a brief introduction of what Kubernetes actually is under the hood. How does it work and what does it do? So this is a high level, very high level overview of what's inside of our Kubernetes cluster. So usually you have a main node, also called the master node, where with the control plane, and then you have different worker nodes. And now in the control plane, we have our API server. And the API server is really like the heart of our Kubernetes cluster. So whenever you send any requests to your Kubernetes cluster through, for example, a tool called kubectl, kubectl, then the API server is responsible to fulfilling that request, to taking care of that request, and make sure that different parts within your Kubernetes cluster will know about what you actually want to do. So the API server is a really central component here. Now, and it's also actually the power of Kubernetes, because it allows so many new features to be added to Kubernetes, but we're not going to really talk about that now. Though the other part is etcd. etcd is a highly available key value storage, and it basically keeps track of everything that's within your cluster, like everything that's stored, such as secrets within your Kubernetes cluster. So it's another like really important part from a security perspective. Then on the control plane, we also have a controller manager. Now within Kubernetes, you have controllers and operators. Now, if you're completely new to this, all you have to remember about controllers and operators within your Kubernetes cluster is that they basically take care of really specific processes within your cluster. So let's assume you usually doing something manually, and you don't want to do that manually within your cluster anymore, or like within your environment. You can get a controller or operator to take care of this process. Now, in this case, the controller manager is really responsible to keep track of the state of your cluster. Like, is everything working as it's supposed to be? Is anything like, what's the state of the cluster? And then we also have the scheduler on the control plane. And the scheduler is basically responsible to know which nodes, which worker nodes are available to schedule new workloads on, to schedule your new deployments on. Now, on the worker nodes, we have kubeproxy, which is important for routing within the cluster. And then we have the kubelet. And the kubelet is really important for the worker nodes. Every worker node will have also its own kubelet. And the kubelet is basically responsible to communicate with the container engine that's within Kubernetes. So the container engine is there to run containers. So it could be, for example, the Docker engine, or it could be containerd or similar. And it's there to run the containers on the worker nodes. And it's communicating with the kubelet, and the kubelet is responsible to make sure that the containers are actually spun up. Now, containers are spun up in a resource called a pod. A pod within Kubernetes is like the smallest resource that you can have. And within a pod, you can have, well, you usually have like one or multiple containers, depending on the use case. I would aim to have one container per pod because it makes debugging a lot easier. But ultimately, this is how it all works together. So here, Kubernetes really is responsible for scheduling, managing, and monitoring your containers. And if you think about it, you can have in some environments, you can have thousands of containers running, right? You don't want to spin them up and manage them all independently, right? You want to have an automated system that kind of abstracts a lot of the underlying components from you, so you can have access to the underlying, or like the lower level components or individual components, such as individual containers, without having to always directly interact with those small resources yourself. So this is ultimately Kubernetes. It's a very complex system. I don't expect you to remember all of the details. Just think about it that there is a part that interacts with the outside world, and there's another part that's responsible to schedule your containers. Next slide. So Kubernetes is ultimately distributed remote command execution as a service. So it adds the additional complexity of being distributed in remote to the mix. Also, depending on your environment, you might even want to have more complexity, such as multi-tenancy. You want to have multiple Kubernetes clusters that all communicate with each other as well. Or you want to have multiple regions where each there's one Kubernetes cluster. And the more complexity you add to the mix, the more difficult it will be to manage it, and the more issues you can face, I guess. But that's ultimately what Kubernetes does. It also helps us in, well, it brings a lot of challenges. It also helps with a lot of the with the lower level management and especially large scale infrastructures. So for example, when I was working as site reliability engineer, and I will talk a bit about that later as well, but we had different regions, and in each region, so for example, in Frankfurt, in London, in New York, we had like a big main cluster. And then within those main clusters, they were basically on each compute rack. And within those compute racks, we had nodes, and each of those nodes could schedule tenant clusters. So we had like main clusters, and within those main clusters, we had then all those tenant clusters. So there's like a lot of different components that you will have to manage. So Kubernetes is essentially orchestrating Docker or like containers. And the same challenges that we have faced directly with containers and issues that we face and security issues we face with containers, we will also have within Kubernetes. But within Kubernetes, we will also have all the additional complexity built on top. So it's not just a container and everything, all of the configurations, everything we can do within the containers directly themselves. But with Kubernetes, we also have the Kubernetes components on top. Here's demo 3 for you.
So in the same way as with Docker, it's possible to get root by executing a container. We can also do that with Kubernetes, because Kubernetes is essentially just orchestrating Docker or similar to Docker containers. So what we're going to do here is we've got a Kubernetes cluster, which currently doesn't have any pods running. And what we're going to do is we're going to create a container inside a pod that's going to give us access to the underlying node. And this is something that any user of Kubernetes could do, unless you've got additional security controls in place. So what we're going to do is we're going to do kubectl create f manifests node root. And then whilst that's creating, we just have a quick look at what we've created. What you can see is a fairly simple Kubernetes pod specification. In there's a couple of things that would look familiar from our previous demonstration around Docker run. You see here we're asking for host resources, and we're also using this security context privilege flag as well. So now hopefully we should have that up and running. What we can do is we can just say kubectl exec -it node root pod root /host. Now, before I run this command, you'll see that I am the root user, but I'm on my local machine. So I'm on a local workstation. Then when I hit enter on this command, we're now the root user on the cluster control plane. That means that anyone who could do this would have full access to the underlying control plane. They could go and, change files, modify things, modify EC shadow, or anything else. And that is by design. This is how Kubernetes works out of the box.
Amazing. Let's go back to the presentation. So ultimately, Kubernetes is really like, you have to imagine it's like a layered cake. I like this comparison. So in a cake, you will also have different ingredients, right? And you have to make sure that the mix of ingredients is right. So the cake actually tastes good. And similar in Kubernetes, you have to make sure that the configurations are right, so you can actually use it properly. The thing is, within Kubernetes, you will have different components, right? You will have maybe on top, you will interact with the Kubernetes cluster, you will have the container runtime, and everything is working on the Linux kernel. So you have all those different layers. And then in addition to that, you have outside components as well, such as your container registry, that you will have to keep in mind, like how secure is you if you're using a private registry? What are the configurations of the container registry that you're using externally? So there are lots of different components. The thing here is that each of those components is managed by different projects, by different interest group, let's say. So for example, the container registry might be provided by Docker, it might be provided by a cloud vendor, or it might be provided by a Git repository such as GitHub. So similar with like all of those different other components, whether or not they're open source, they will have different projects behind that are ultimately managing those components and that are working on those components, and they have different interests and different goals. And the other thing here is that people, maintainers who are working lower down the stack, right, who are not having in mind containerization and Kubernetes and all the cloud native things on top, they will not take that into consideration, right? It will not. So a lot of it will work, or like people will work on it independently. And I've seen like Kubernetes installations or platforms that didn't care really about what's actually going on under the hood, and abstracted so much away that you could actually not really understand what's going on underneath. And in a complex system such as Kubernetes, you really do want to have the option to also understand the different components underneath that you might not be interacting with on a day-to-day basis. The other thing is that each of those components will have different container security issues, container breakups, and those are different CVEs. Rory knows them all by heart. Like if you ask him about specific CVEs, he will know the entire number, like everything by heart, which is fascinating. So try it out when you have a chance to meet him. Ultimately, what I want to, like the point of this slide is really that while you do like run containers high up on the stack on, for example, through Kubernetes, through your cloud native environment, it can be affected by issues further down, and you will have to keep that in mind. So just understanding the top, which is already a lot, you will still have to pay attention to everything that's running underneath. Here's demo number 4 for you.
So to demonstrate one of the vulnerabilities that can occur in the container stack, let's look at CVE 2022-23648, which is a vulnerability in container D. What we can see in order to exploit this vulnerability is that we have a container file here, which has a pretty standard setup from an entry point, and then we've got this volume line here, which what it does here is it goes ... so directory traversal, and then the PKI directory for the kubelet. This contains sensitive information such as the private key of the kubelet. So if an attacker can get access to this by running this container, then obviously they can then use that to try and get additional access to the cluster. So what we're going to do is we're going to create that manifest inside the cluster, and then what we're going to do is we're going to do exec -t and actually execute into the container, and then do look inside that directory. Now typically this image shouldn't have any files in that directory, but with this vulnerability it's been possible to copy those files in from the underlying host, and we can see that if we do this, and here you can see we have the kubelet's private key. So because this cluster is vulnerable to this issue in container D, it's possible to get access to privileged files from the underlying host.
Amazing. Well, again, this is really like to show those issues. Now, let's move on to some other parts and issues within Kubernetes that are maybe more specific. So this slide was titled by Rory, Kubernetes networking is fun. I don't think it's fun, it's very complex to me. Ultimately, what you have to remember in Kubernetes networking is that it reuses a lot of the Linux networking features. So it's adapting a lot of the Linux networking features to Kubernetes and building on top. The problem, or like not the problem, but the thing is that Kubernetes changes or builds on parts of it and modifies it. So some parts will work differently. And that kind of builds up some sharp edges, as Rory calls them, that we have to be aware of. Ultimately, we have to think of cluster nodes are routers. So by default, in many clusters, you can't get to the container network from outside the cluster. But ultimately, cluster nodes are routers. So the thing is that when you're like in an on-premise clusters, you would have a separate subnet for the cluster that you can't access from the outside world. Now, the thing is that if you're on the same IP subnet as the cluster, you will be able to access the container traffic of the cluster itself. Just one of those things. No, here's demo 5.
So we can demonstrate the idea that Kubernetes cluster nodes are just routers by showing what happens if you try to get access to a pod from outside the cluster. The machine we're currently on is a machine on the same network, but not inside the cluster. We can have a look and see what IP addresses we're looking for with kubectl get po -o wide. And we can see here, we've got a pod called testweb, which has got an IP address of 10.0.1.71. Now, if we try and curl that address, initially we'll get no response, right? Because we can't get that network, we can't route traffic to it from outside of the cluster. However, if we do sudo root add net 10.0.0.0 net mask 255.0.0.0 GW, and then we use the gateway of the cluster node IP address, which in this case is 192.68.41.78. We can now try and curl that again. And when we do so, we get back the response from the pod inside the container network. Because Kubernetes nodes are just routers, and if you tell your local machine that you need to route traffic into the cluster, it will happily do just that.
Okay, so let's discuss some specific CVEs. So this is Tyler, awareness localhost, not only local. As part of Kubernetes, using Linux networking, it means that you can configure the network stack on the cluster nodes. And one setting used by Kubernetes that had some interesting consequences. So it is related to an older version of Kubernetes where basically you could access the container's local host from somewhere else on the local network, which should not be possible. Now let me share the next thema. Theme 6.
So we can demonstrate this vulnerability and show that in a situation where the cluster is vulnerable, we can actually get access to a port running on the local host interface of a remote machine from another system in the network. To start off, what we're going to do is we are going to show that there's no Kubernetes cluster running locally. And it's going to say, nope, you can't get access to that because we don't have a cluster running on this port on localhost. So then what we need to do is tell our cluster to allow us to send localhost traffic to a remote machine. To do that, we need to set some sysctls, which will allow us to do this because it's a pretty non-standard Linux configuration, but Linux being fairly flexible will allow us to make these changes. These two commands just allow us to move traffic to localhost traffic to remote machines. We then need to modify our routing table. So first off, we remove the route that sends this host traffic to 127.0.0.1 to the local machine and have it route out to our vulnerable Kubernetes cluster, which in this case is on 41.93. So now we should have a route set so that it'll actually go to the cluster, and we should be able to replay our kubectl command from before and see if it'll give us access to the cluster that happens to be running on this port on that machine. And as you can see, that now works, indicating that we've been able to successfully exploit this vulnerability.
Okay, let me go back to the presentation. So another CVE, attack of the services. I think there was an amazing title. I might call a KubeCon talk that. But ultimately, the thing is here that Kubernetes adds a lot of different components on top to make networking between different components, such as pods, happen. So the thing is, pods are ephemeral. I never know how to pronounce the word, but basically pods are there to, they're not there to be persistent. Like they live and die very quickly. Like there are lots of things that can break a pod from different configurations to it just, dying every once in a while. So basically pods are not like a reliable connection, let's say. Every pod that is spin up will have its own IP address, and then you could use that to configure within the everything within the cluster. But ultimately, the next time a new pod is spin up, it will have a different IP address. So you can't really have the data be persistent across your cluster over time without having to reconfigure everything all the time. So what Kubernetes did is building services kind of as a wrapper around that. So you can connect services in Kubernetes with the pods, with the underlying workloads, and through that you will connect the different services with each other, and the pods underneath, they can do whatever they want. It won't affect the networking of the services. So the thing is that that this CVE basically showed consequence of malicious services. What this CVE was about is that basically anybody who is able to create on a Kubernetes cluster service will be able to intercept the traffic of other services within the cluster. And there's no patch for this out of the box within Kubernetes. However, you can use admission controllers to kind of mitigate that. So you can use the admission controller that comes through Kubernetes, or you can use other additional admission controllers. And yeah, that's basically the issue. So just because you have access, or like when you have access to one part of the cluster, it can easily happen that you can have access to other parts, even though it's not, the configuration between the different services is not explicit. So the next demo.
So we can demonstrate CVE 2020-8554 in a standard cluster, as by default is not mitigated unless you deploy additional admission controllers. Here we've got a Kubernetes cluster, just an empty cluster. And the first thing we're going to do is we're going to create a client pod. And this just spins up a pod for us. And then from inside that client pod, what we're going to do is we're going to curl an address on the internet. In this case, the ICANN has IP service, and just see what it comes back with. So kubectl exec client pod, and then curl -s ICANN.com. And what you see is you come back with, this is my external internet facing IP address, which is what ICANN has IP is meant to do. It just basically returns your internet IP address. So now what we're going to do is we're going to deploy a service which actually intercepts that call. And this is something that any service owner can do in a cluster by intercepting the IP address for that service. And then we're also going to spin up a server to actually redirect it to. So let's do that. So first we're going to create the server that's going to receive our redirected traffic. And then what we're going to do is we're going to create a service which essentially is going to intercept that traffic and send it in the other direction. So we can actually quickly look at the service as well. And you can see here what we're doing. These are the external IP addresses which correspond to ICANN has IP's servers. So this is essentially what we're going to hijack. So now if we run the same command we did before, which is just literally to use curl to go to the ICANN has IP server address, what we get back is not what we got before. We get back, this is essentially the echo server which we deployed, which is where we redirected the traffic to. So essentially, if you think about this, this would allow an attacker who can create services to intercept traffic for some other user in the cluster and direct it somewhere else that they want to send it.
Okay. So how does the attack vector or security within Kubernetes actually evolve, or like how does Rory see it change? So with more and more people joining the ecosystem, obviously first of all, there are more people who don't have detailed understanding of those underlying components and all of their details around it. And at the same time, you have projects that kind of, they try to make Kubernetes less complex. What I mentioned earlier, that a lot of projects try to abstract as much of the underlying components as possible. The thing is, the complexity underneath, even if you try to abstract it, won't go away, right? So first of all, Kubernetes has IPv4 and 6 dual stack clusters released to stable. So that's a component to it. And then also there are lots of container network interface add-ons for Kubernetes, such as Cilium. So you can, like, as Kubernetes becomes more mature, the networking part is actually becoming more tailored to specific use cases and specific type of clusters, specific environments. So with network plugins from that are provided by a specific group, you can actually also create your own network interface and similar, versus using like a project such as Cilium instead. So that's one of the things that's going to add more complexity to the entire ecosystem to running Kubernetes clusters and workloads within. Another part is what I mentioned earlier, that as the ecosystem becomes more mature, like as many companies are expanding their usage and making their usage of Kubernetes more complex, this will also add a lot of more areas to the mix of like things that you have to take into consideration for your container security, such as through multi-tenancy. How do you make sure that in multi regions, how do you make sure that different clusters and different components within the clusters can reliably communicate with each other, even if they are not in proximity? So the next part is, something else that's really specific to Kubernetes is that Kubernetes, unlike other multi-user systems, it doesn't have user accounts. So you don't have like by default like a list of different users who can access your cluster, meaning you have to find other ways to keep track of who can actually access your resources, which is a lot of fun. So how does Kubernetes ultimately do it? How do they know that the request is legitimate? It's really through the authentication mechanisms that you're using. So for example, through the authentication mechanisms of the cloud provider. So for instance, if I have limited access on my Google Cloud account to different resources and what I can modify, then obviously, then also you can like configure the access within the Kubernetes cluster. You can also add additional access rights of like, maybe I'm only allowed to access specific namespace or similar within that cluster or specific resources. Here's demo 8.
So as mentioned on the previous slide, Kubernetes itself doesn't have a user database, but relies on external authenticators and the identity they provide. And we can actually look at this by looking at some of the identities used in a kind of standard Kubernetes cluster. The first one, what we're going to do is we're going to use this command here to extract information from the kubeconfig file, which is how users often authenticate to clusters. And we're going to get the client certificate data and have a look and see what user we are actually authenticating to as this cluster. So this gives us out our information, and we can see here that in this case, the username that we are using is the CM field, which is Kubernetes admin, and the group name is system masters. And we'll talk a bit more about system masters in the next slide. So that user essentially is usernames Kubernetes admin and a group of system masters. Also, Kubernetes has service account tokens, which is how services authenticate into the cluster. And we can do a similar idea. These are JWT tokens, as we mentioned, so we can look at how they are constructed and what username is being presented there as well. So here, what we're going to do is get the default secret from the default namespace, and we're going to decode that and have a look at what it looks like. And here, what we can see is that we've got our subject name here, which is system service account default. So it's the default service account in the default namespace. So that's the username that would be used for any role-based access control decisions there. One thing you might notice here, if you're used to JWTs, is what's missing. And what's missing is any form of expiry. These tokens don't expire, they last forever. So any user who's able to get access to one of these tokens will actually have persistent access to the cluster. And this is something which has been addressed or being addressed in the most recent versions of Kubernetes, specifically in about 1.22 and above. Workloads don't actually use these anymore, they use time-bound tokens. And we can actually look at one of those tokens by looking at a workload that's running in our cluster and looking at what the token is for that. So if we do kubectl get PO, we can see here we've got something called test web, which is just a pod running in our cluster, and we can look and see what token that is running. We do that using this command here. We're going to exec inside the test web pod, and we're going to cat var run secrets kubernetes.io service account token, which is the default location. This is still a JWT token, and we can actually then look at what it looks like. And here, what you can see is the subject, interestingly, is the same, right? This isn't the same token, but it's got the same subject. It just, because all workloads get assigned the default service account token if they don't have one of their own. But what we do have here is an expiry. So these tokens that are used in more modern versions of Kubernetes actually do expire, which obviously is great from a security standpoint. But that is how Kubernetes decides on the user identity, because it doesn't have its own database.
Okay. So another thing is that there's a, I hope you can't see. Oh, okay, here we go. So there's a group within Kubernetes called System Masters, and they have by default hard-coded cluster admin rights within your cluster. And this is like by default there. And any group, like any valid group within your cluster will have, who's part of that group, of the System Masters group, will have by default also cluster admin rights within your cluster, which is something that you should be aware of, because you don't want to accidentally make a user part of this group, the System Master group, because then they will have cluster admin rights, right? Here's the last demo.
So if you remember from the previous demonstration, the user we are currently connected to this cluster as uses the group system masters, which, as we just explained, is a hard-coded group which gets administrator rights to the cluster. And we can actually demonstrate exactly how the fact it doesn't actually use the RBAC system with a couple of simple Kubernetes commands. We're going to run the command kubectl auth cani list, which lists the permissions that a user's got. And you can see here at the top, we have star.star, so we've got everything. And that's obviously via the RBAC. Well, that is via the RBAC system. So say for the sake of argument, we then delete this access. We essentially delete the rights we've got. So what we can do here is we can say kubectl delete cluster role binding cluster admin. And it will remove that. If we now run the command again, kubectl auth cani list, you'll see we no longer have that star.star. So in reality, we shouldn't be able to do anything. These are just the default rights that any authenticated user gets. We have no rights to any resources. So in theory, we shouldn't be able to do anything. However, if I do kubectl get po as n kube system, we see we still have all the rights we used to have. Even though the RBAC system doesn't think we've got any rights, because we're a member of system masters, we essentially bypass that entire service and retain our access, which is why you need to be so very careful with giving anyone membership of that group.
Okay, so the last thing that we're going to cover is the Kubernetes ultimately follows REST API structure, but for parts of it, let's say. So here, the parts that are generally thought of as REST API, of like the different changes that you can make to resources. However, then we have within RBAC, we have restless verbs. That's not part of it. Now I'm just skimming over it because I know I have like 10 minutes left and I want to have maybe some time for questions. So here, but Kubernetes itself doesn't have an understanding of like users. RBAC has person that work on users and groups. Now, concluding of all of them, everything I just told you about in this presentation, containers and Kubernetes are becoming ubiquitous in modern IT environment. It's there, and sooner or later, if you're in your IT career, you probably have to get started with it if you haven't already. They're complex systems with lots of different layers. A friend of mine constantly tells me you either want to be a Linux expert or you want to be a Kubernetes expert in order to deal with Kubernetes. I'm still working on both. So they're obviously, because it's such a complex system, there are plenty of possibilities for vulnerabilities, for misconfigurations to make things more difficult. Now, there's lots of like, also for people who are getting started with Kubernetes, something that helped me a lot is like using misconfiguration and security scanners to just tell me like, hey, maybe you want to configure your resources differently because you're exposing yourself to unnecessary security risks. Things like that you don't know when you're just getting started, but misconfiguration scanners will tell you that. And then the last thing to remember is if you don't understand a component within Kubernetes, look at how this similar component works within Linux. Since Kubernetes is re-implementing a lot of Linux primitives. And that's it. I think I have still some minutes for questions. However, since you have to bear in mind that I just gave this presentation, right? I might not be able to answer your question. So the best thing is, if you have more complex questions, reach out to Rory. Here's his Twitter handle. Also, if you don't have Twitter, he's on LinkedIn, so you can find him there at Rory McCune. And then there's my Twitter as well. If you like this presentation, you want to see more of my presentations, for example. Okay, thank you so much.
Awesome, Anais, that was an amazing presentation. So would you like to hear the 2 questions that you've received in the Q&A?
I can see. Let's see if I can answer them. If not, then please put them on Twitter or send them to us. Or I'm gonna go on the platform afterwards, and I'm sure like I can find all the questions, and I'm gonna make sure if I can't answer them, I'm gonna post like anonymously the answers with Rory. So we're gonna make sure we answer them. But yeah, are there questions?
There are indeed, you have 2, and they're good ones. So the first one is, why still use Docker when it's obsolete in Kubernetes 1.24?
So the thing is, that Kubernetes doesn't, like the project, make the decision to replace the Docker engine with Containerd as its container runtime. Now, Docker is not just it's not just the container runtime, it's also like you have Docker desktop to view your containers and to build containers, to manage containers. You have the Docker Hub, right? Like there are lots of different components. When we're talking about Docker, we actually should really specify what are we talking about, right? Like Docker is still, like from my perspective, like to build containers and just test them without Kubernetes. It has a nice UX. It's user friendly. It's beginner friendly, and that's personally why I would use use Docker to build my containers. Now you can use other tools as well to build containers. There's some for example, Red Hat has one. I think with Rancher you can do it as well. So there are different tools with which you can also that offer similar functionality, but ultimately I would view it as like the tools that you use to manage and build, not manage, to build your containers and to test them out are kind of separate then, like they're more at the beginning of your development and testing workflow, versus once you have the container image, you can store it on any container registry. You don't have to store it on the Docker Hub. And that's kind of then when you will leave kind of the Docker specific ecosystem, and where it doesn't really like for example, for me, it really I haven't really seen a difference using different Kubernetes versions between the different runtimes and my containers. Like it just like obviously for specific, like for the details, you want to pay attention to that, but ultimately if you have the container, it doesn't so much matter to you in a lot of ways, like the underlying runtime within your cluster. And I mean, that really depends on your environment again, but we have to be, when we're talking about Docker, we have to be specific. What part are we actually talking about? So when we said here in this presentation Docker, we referred to actually the containers, like it applies to all containers, not just Docker containers. Yeah, hope that answers the question. If not, please reach out.
One down, one to go. So we've got one here from Andrew as well. If in the demo we can connect to a Kubernetes cluster remotely, does that mean we should be keeping clusters behind the DMZ?
So yes, well, I would. So we had like when I was working as site reliability engineer, I obviously had to access not only our regional clusters from my local work machine, right? Because I didn't have access to those data centers, for instance. And we used a VPN that you had to be on to ultimately access the kubeconfig and access the clusters. So you want to have additional security measures in place that can prevent anybody who has the kubeconfig to just access the cluster itself as well.